Alright, good morning. Sorry about that. This lesson is for my Trig-Precalc classes Wednesday, April 1st. It's April Fool's Day. I normally have an April Fool's prank that I play on my students. I'll tell you what it is. So I'll walk into the class and I'll say, oh, today I was going to give you a test, but the printer wasn't working, and then you guys get all excited and go, yay! And then I go, April Fool's, the printer was working, here's your test. So unfortunately I can't play that prank on you, but I love that prank. It's so wonderful to see the range of emotions. It's almost like a sine graph. It is a sine graph. Anyways, I hope everyone's doing okay out there. Again, if there's anything that that I can help you with, please reach out and let me know. I hope everyone is doing okay. So I'd like to talk about our goals today. I was thinking about, should I teach this lesson or not? And it's one of these things that it's an overcomplicated method to solve the equations. However, I don't know why I'm moving forward with it, but I just kind of feel that I think I'm going to justify teaching this lesson because I had to do it. You guys have to do it. But there is still valuable concepts that we will review in this lesson. So I'll make that the point of the lesson, is just the opportunity to review. Today is literally probably the only time you'll ever be asked to solve using this method. But again, let's make the review. The main concept here, the homework. It's going to be pretty easy. I'm probably going to have some of you solve the problems in another method, but again, try to do the method that I'm going to teach today. Alright, so there's 3 goals today. I want to review the idea of inverses. I want to talk about exponential and logarithmic inverses, and then I want to solve equations using inverses. Alright, and so let's go ahead and start with the first goal of reviewing inverses. Remember, an inverse for a function, or an inverse in general, means that you get the identity, right? So 5 and negative 5 are additive inverses, because when you add 5 with negative 5 you get 0, and 0 is the additive identity. There's the multiplicative identity, 1 times 1 over 5, the 5's cancel, you're left with 1. 1 is a multiplicative identity. So remember, inverses lead to identities. In the world of functions, x is the identity, because when you plug in x into an equation, you get the exact same equation back, because x doesn't change what x is. It's the identity. So I'm reminding you here, what I'm showing you is that I'm plugging in this function g into the f function, and getting x back implies that they're inverses, and when I reverse the order and plug the f function into the g function and also get the x back, this verifies to me that these are inverses, right? Remember, plugging one function into the other and getting x. That is how we find the inverses. Remember, to find the inverses, what we're going to do is we're going to switch the x and the y and solve for y. So, again, I think this lesson is good for review. So I'm going to check off the first goal. Remember, inverses for functions mean you plug one into the other, you get x back. And so let's take a couple of seconds here and find the inverses for exponential and logarithmic problems. And remember, all that we're going to do is we're going to switch the x and the y and then solve for y. Alright, so I have my logarithmic function, and so what I'm going to do is I'm going to switch the x and the y, and I'm going to now isolate my y. Remember, to isolate the y, we go from the logarithmic form to the exponential form. So my inverse to this function is going to be this function. And if I was to plug this in for my x, which I will do, just like I plugged that function in for that x, I should get x back. Alright, so let's see here. So I'm going to take this and replace that x. So now I get log base b, and I'm replacing that x with b of x. And we'll just say that that's equal to something called question mark. Again, you want to rewrite the logarithmics as exponentials, so it's going to be b to the question mark power is equal to b to the x power. And since the bases are the same, that implies the exponents must also be the same. And so the question mark is equal to x. So when I plug this into this, I get x. So this is an inverse. And, you know, I should write this down somewhere to see how high up this goes. We'll hold that thought. I'll write this in the next section. This is an inverse. I'll write it again. Alright, so I want to find the inverse for the exponential. I found the inverse for the logarithmic. I'm going to find the inverse for the exponential here. Alright, so again, the very first thing I do is I switch the x and y. And logarithmic functions allow me to isolate exponents. So if I want to get the exponent by itself, I rewrite this as a log. And I get log base b of x is equal to y. And we just say now it's y. So this is the inverse of this. So what happens is what I'm going to do now is I'm going to plug this in for my x. So instead of plugging this into that, I'm going to switch it, right? So I'm going to now get b. I'm going to replace this x with this whole thing to the log base b to the x power, or b to the log base b of x. And again, we'll just say that this is equal to question mark. Here I have an exponential. I'm going to rewrite it as a log. Like here, I wrote this exponential as a log, so I'm going to rewrite this as a log. So it's going to become now log base b. I have to think here for a second. Log base b of the question mark is equal to log base b of the x. Remember, the exponent is isolated when I rewrite something as a log. This was my exponent. Now, I have logs with the same base on both sides of the equation, which implies that question mark must equal to x. So, b to the power log base b of x must also equal to x, just like log base b of b to the x power. That itself must also equal x. All right. So I'm going to write these two inverse concepts before I talk about solving equations using inverses. And again, it's a little bit more of a overkill on the algebraic side, but again, I think it's just a good practice as well with the algebra skills. So the problems that you're asked to do aren't very crazy. I think I gave you 6 of them. And they're meant to be pretty easy. You're not going to get exact answers. Just leave them as they are. That's fine. All right, so let's move into the last goal. And that's going to be to solve equations using the inverses. Okay, so before I do that, I'm going to write a couple ideas down. If a number raised to an x power is equal to that same number raised to the y power, what that means is I know that x must be equal to y. But if I know this, I can go backwards and I can now make these guys exponents. Okay? So again, we're going to turn an equation into exponents. The next thing I want to point out is if log base b of x is log base b of x is equal to, I'm having a hard time today, log base b of y. If I know this, I can interchange that, or not interchange that. If logs with the same base are equal, then their of numbers must also be equal. Now, if I have an equation, I can rewrite the equation using logs. I can, excuse me, I can rewrite this in any such way. Ratchet method. Sorry about that. Alright. And then what we just figured out, is that log base b of b to the x power, that must be equal to the exponent. And we also figured out that b raised to the log base b of x, that also must be equal to x. So these are our tools that we have. Okay, and so I'm going to just write a simple little equation here. Let's say I give you something that looks like, oh, I don't know, 3 to the x equals 215. Alright, so again, this is like such an overkill problem because you're going to be doing things that you don't need to do. Honestly, if you wanted to solve this, you would just rewrite it as a log, and the answer would be log base 3 of 15 is equal to x. That's how we would solve it in the simple way. But for whatever reason, in this trig book, and they have this method of solving, and I don't know why it's in there, but again, it's just a little practice in algebra. And we got to review inverses, so I will play along with what the book recommends to teach on this one. All right, so now I'm either going to use this idea or I'm going to use this idea. And so what you need to figure out in order to solve it using what we created today is, are you starting out with an equation that has an exponential, or are you starting out with an equation that has a log? And if your equation starts out with an exponential, you are using this. If your equation starts out with a log, you are using that. So I have this. So I'm going to use this concept, right? So we're going to say that we're here, and we want to rewrite this using logs. Now notice that these are the same. So I'm going to rewrite this in such a way that my log base is going to be the same number as my base in the equation. So I'm going to turn this into this. So it's now going to be log base 3 of 3x, 3 to the x, I'm sorry, 3 to the x, and that's equal to log base 3 of 15. Again, like I said, this is such overkill. It's a lot of unnecessary steps. Alright, so I've created now this situation, and I know that this itself just turns into x. So x equals log base 3 of 15. So I solved for that, right? And so again, I recognize I started off with an exponential, so I need to use this. Let's start off with a log and use this idea, and then that should wrap up today's lesson. Okay. So let me, I'll write a little note here. Start with an exponential, and this one we start with a log. Okay, so that was example 1. Example 2, I'll do log. Let's get out of the way for a sec so you can write that all down or pause it. Alright, so let's start off with a log equation. So if I gave you log of x equals, oh, I don't know, 31. Remember, if there's no number here, I'm implying that I have log base 10 of x equals 31. Again, if you were to solve this, the easy way to solve this is you would just rewrite it as an exponential. So it would be 10 to the 3 power. Or sorry, 10 to the 31st power equals to x. It's a huge number. Alright, so again, this is a very simple problem to solve. but we're going to use the inverse properties to do it. So I'm starting off with a log in my equation. So I'm going to try to create this situation. I want my log to be my exponent, right? So I'm going to look at what I'm starting off with as this idea, and I'm going to put the same base on both sides. And notice here that whatever number is here is the base that I want. So I'm going to rewrite this equation as 10 to the power log base 10 of x, and that's equal to 10 to the 31. Now again, I've created my inverse. I've built this. And I know that if I have a number raised to the log base b, these numbers have to be the same of x. Whatever that number is gets to become just that, right? So this whole complicated looking thing just gets to turn into x, and x equals 10 to the 31st power. You see our answers are the same, but this is a more complicated way to do it. There's only 6 of these problems. Please try your best on this. Let me also, let's make sure we're taking attendance here. Take a second, do the attendance. Let's help out the attendance ladies. They're probably way overwhelmed. And let's not add work on our side. Again, if anybody needs anything, reach out, let me know. I will try my best to get back to you as soon as possible. Help you out. I hope, again, everyone is doing well. Please, 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 again, make sure you're doing the assignments. If you've fallen behind, I'll let you make them up. Just turn them in. Let's make sure that we get through this quarantine and put ourselves in a good position. And again, if there's anything that I can do to help, if you're having internet problems, you need a device, you need more time, the school's feeding students, please let me know. I can help you guys out. Again, I hope everyone's doing all right. I will post the next video in 2 days. I need to write the next homework assignment. So again, have a good day. See you in a couple.